Okay, so welcome back. This is our video number 5 of our summer video series for pre-calculus. And in this video, we are going to look at solving radical equations. So before we get into solving the equations, one very important point is to look at the radical. Remember, radicals are roots, right? So if I have the square root of x and I square that, what am I actually going to get? Well, the square root of x can be written as x to the 1/2 and square it. But what do we do when we have exponents that are outside the parenthesis? We multiply them. So this becomes x. So simply put, if I square a square root, it just gets rid of the square root. Okay? So let's apply that to solving some basic radical equations. If I have the square root of x equals 3, well, in order to solve that equation, I'm going to square both sides. And when I do that, I get x equals 3 squared, which is 9. If we were to check that, we could plug it back in. The square root of 9 equals 3, and that is true. Now, we've learned all along that the square root of 9, not all along, but you learned in Honors Algebra 2, the square root of 9 is actually plus or minus 3. But when we're looking at equations like this, when we're solving equations, the absence of a plus or minus here implies that we're actually only talking about the positive square root. If it was the negative square root, it would actually have a negative sign outside that square root. Okay, so when we're solving equations, the absence of a plus or minus means we're only looking at the positive root. Okay, so let's just apply this simple method to some more complex versions. So let's look at something like this. The square root of 4 minus x equals the square root of negative 2 minus 3x. Okay, so we're going to square both sides. And when we square a square root, it gets rid of the square root. So this is just 4 minus x equals negative 2 minus 3x. Now we just have a simple equation to solve. So I'm going to add 3x to both sides. Gives me 2x on the left. And then I'll subtract 4 and get negative 6. Dividing by 2, we get x equals negative 3. So we always have to go back and check our answer when we're talking about radical equations. So we're going to check it just by plugging it back in. So we're going to plug in negative 3. So I get 4 plus 3 equals square root of negative 2 plus 9. So we have the square root of 7 equals the square root of 7. And that's true. So there's my solution. Okay. Okay, let's look at another one. Let's look at the square root of negative 10 plus 11x equals x. Okay, so once again, I am going to square both sides. And when we do that, square root drops out here, so I have negative 10 plus 11x equals x squared. Now this one's a little harder because I actually have a quadratic equation to solve. And remember, quadratic equations have to equal 0 in order to solve them. So I am going to subtract 11x and add 10 to both sides. Okay, and over here we get 0, and that equals x squared minus 11x plus 10. Okay, very important. Notice I moved this side over as opposed to moving the x squared over. The reason I did that is that I want to keep this leading term positive. It's not incorrect to do it the other way, but it makes it more complicated, right? We want to keep that x squared positive because that makes the factoring much easier. So we're going to factor this. So we have 0 equals, now I'm looking for two numbers that add up to positive 10. I'm sorry, multiply to positive 10, but add to negative 11. So that's going to be x minus 10, x minus 1. I have x minus 10 equals 0. Oops. And I have x minus 1 equals 0. So x equals 10 or x equals 1. So we're going to go back up to the original problem and we're going to check both of our answers. So we have the square root of negative 10. I'm going to check the x equals 10 first. Negative 10 plus 11 times 10 is 110 equals 10. So this will give me the square root of 100 equals 10. And the square root of 100 is 10. So we get 10 equals 10. And we're good. So that worked. Now let's check x equals 1. So we have the square root of negative 10 plus 11 equals 1. So that's the square root of 1 equals 1, and that's true. So these both work, so I have two solutions. Okay. Let's just look at this graphically to make sure you understand what's happening. Go to my calculator, and I'm in y equals. I've got the square root of negative 10 plus 11x. And then in y2, I'm going to put x. So I've got both lines there, and I'm looking to see, I can erase some of this. I'm looking to see where they're equal to each other. So graphically speaking, I'm looking to see where their lines intersect. Okay, and if we look at it, it looks like I need to adjust my graph because I can't see this point of intersection up here. So I'm going to go into my window and I'm going to change my X max, and let's make that 25 and graph it. Okay, I still can't quite see it, so I'm going to keep adjusting my graph. Oh, that's because I changed the wrong thing. Oh, that was so silly. Y max, not X max. Okay, there we go. So I'm going to see what those points of intersection are. So I'm going to do a calculate intersect, first curve, second curve, and then I'm going to move it close to that point of intersection. Okay, so it tells me that point intersects at x equals 10. And then I can check the other point of intersection. First curve, second curve, and I'm going to move it the other direction so that I'm down here close to that point for center. And I get x equals 1. So what we see is that this particular curve, right, let me just zoom in a little bit. right, is actually intersecting in two places, down here at x equals 1 and up here at x equals 10. Okay, so that has two places where that line intersects it. Okay, let's look at another example. Let's look at 10 plus the square root of -3 minus 21x equals 19. Okay, so unlike the others, I can't just square both sides. So notice in the other two problems that I showed you, the first one, right, we had a square root on both sides, but it was just one square root, right? So when I square both sides, it got rid of the square root. In this example, I had a square root on one side and then just an x on the other side. So squaring both sides was no big deal. Well, here, I want to get this square root by itself before I actually start squaring both sides. So what I'm going to do is subtract 10 from both sides first. Okay, when we do that, we get the square root of 3 minus 21x equals 9. Now I'm going to be able to square both sides because I've got this square root isolated. So we want to try to isolate the square root if at all possible, because that's going to make everything a lot more simple. Okay, so when I square this, now I'm left with a 3 minus 21x. And when I square the 9, I'm left with 81. So we have negative 21x equals, what did I do there? Did I make a mistake? Oh, this is a negative 3. There you go. Sorry. Adding 3 to both sides, I get 84. So x divided by negative 21, we get x equals negative 4. And when I go back and check that, that's going to give me, we always go back to the original problem, 10 plus the square root of negative 3 plus 84 equals 19. So that's 10 plus the square root of 81 equals 19. So 10 plus 9 equals 19, and that's true. So there's my solution. Okay, so let's look at this one. Here we have b equals the square root of 12 minus b. Okay, so this time the square root is isolated, so I don't have to do anything there. I'm just going to square both sides. Okay, so we're going to get b squared equals 12 minus b. It's quadratic, so we want to move everything over to the other side. So this is going to be b squared plus b minus 12. So I factor this, b plus 4, b minus 3. So b plus 4 equals 0, b minus 3 equals 0. So b equals negative 4, b equals positive 3. Again, we need to check it. So going back up to the original equation, we're going to check the b equals negative 4. So we get negative 4 equals the square root of 12 minus negative 4. So that's negative 4 equals the square root of 12 plus 4, which gives me the square root of 16. But the square root of 16 is positive 4. Remember, I know that this is normally a plus or negative 4, But since there is no plus or minus in front of that radical, we're only talking about the positive square root. Therefore, when I take the square root of 16, I'm only looking at the positive square root, which is positive 4. This is not true. So b equals negative 4 doesn't work. So we cross that out. That's called an extraneous solution. It's a solution that doesn't actually work. Okay, extraneous solution. So when it says to check for extraneous solutions, that's what we're doing. We're plugging it back in to make sure that everything works. Okay, let's check the b equals positive 3. So that's going to be positive 3 equals the square root of 12 minus 3. So 3 equals the square root of 9, which is true. 3 equals 3, that's true. So there's my solution. Now, if I were to graph this, I would find that it only intersects in one spot. Okay, let's actually do that. All right, so we've got square root of 12 minus x. Get rid of the other stuff. And down here, I've just got x. So I'm going to graph in a standard window. And we see it's only intersecting in one spot. Okay. If you're not sure, we can zoom out. Okay. And it's clear that that blue line is never going to cross the red line again. Okay. Okay. So we're getting to some unique problems. Let's look at this one. Let's look at a minus 2 equals the square root of a plus 54. So here I see the radical is isolated. So we're going to square both sides. Now we have to be careful because on the right, I have a plus 54. On the left, I am squaring a minus 2. So be careful because the common mistake here, and it's very common, but it's a mistake. The common mistake is that people distribute this 2. No, that is wrong. That's not what we want to do. We can't distribute the 2. A minus 2 squared means a minus 2 times a minus 2. That gives us a squared minus 2a minus 2a plus 4. So we have a squared minus 4a plus 4. Okay, we have to FOIL that out or distribute it out. Okay. Okay, now we have a quadratic, so we need to get everything over to one side. So I'm going to subtract a and subtract 54. So we have a squared minus 5a minus 50 equals 0. That's going to give me a, I'm going to factor this, minus 10 times a plus 5. So we have a minus 10 equals 0. A plus 5 equals 0. That means a equals 10 or a equals negative 5. Okay, we're going to go back and we're going to check our solutions. Okay, so checking our solutions, a equals 10. So that's going to give me 10 minus 2 equals the square root of 10 plus 54. So we get 8 equals the square root of 64. So 8 equals 8, and that's true. We're going to check the a equals negative 5. And we get negative 5 minus 2 equals the square root of negative 5 plus 54. So negative 7 equals the square root of 49. And that is not true, because the square root of 49 is 7. So that's not true. So this doesn't work. That is an extraneous solution. That means a equals 10 is my only solution. Okay, let's look at another one. So this time we have negative 2 equals the square root of, let's see, 6a minus 5. I don't know why I drew that so long. Let's do that again. And then we're going to do minus a. Okay. Okay, so here we see that we do not have the square root isolated. It needs to be by itself. So we're going to add a to both sides of the equation. So over here I'm going to get a minus 2, and then over here we have the square root of 6a minus 5. Okay, so now we're ready to square both sides. So we get a minus 2 squared equals 6a minus 5. Just like before, I need to FOIL this out. This is going to give me a squared minus 4a plus 4 equals 6a minus 5. Okay, so now we need to get it equal to 0, so we'll subtract 6a and we'll add 5. So we get a squared minus 10a plus 9 equals 0. That gives me a minus 1 times a minus 9 equals 0. So that means a minus 1 equals 0, which means a equals 1. A minus 9 equals 0, which means a equals 9. Now when I check these, a equals 1 and a equals 9. The a equals 1 is not going to work. Okay, so we're going to get negative 2 equals the square root of 6 minus 5 minus 1. So that's negative 2 equals the square root of 1 minus 1. So we get negative 2 equals 0, which is not true. But the a equals 9 will actually work. Okay, so this didn't work. A equals 9 does work. So there's that solution. Okay, we're going to stop it there. At the bottom of the video, you see a link for a worksheet that I would like you to work on, and make sure that you plan to hand that in at the beginning of the school year. So just a reminder, there's a link below the video for the worksheet. Do not open it in Google Classroom. You want to open it as a PDF or print it off or complete it in Notability. But do not open it in Google Classroom, because a lot of times Google Classroom does not read the symbols correctly. So if the equation has the square root of x plus 3, it may not read the square root symbol correctly. So do not open it in Google Docs, but open it as a PDF or print it or do it in Notability. All of your assignments for these summer assignments are due the first day of school. It is very important that you complete these. If you don't, you're going to start off with a bad grade and you're going to start off behind because I do not plan to cover this material. Okay, this is all stuff that we need to make sure you know before you start pre-calculus. Okay, if you have any questions, feel free to email me. And my email is bmurray@johncarrollhigh.com. If you have any questions, feel free to email me.